In the last previous two sessions, we have seen FDMA and CDMA, but we have not seen the basics of multi-user systems. In today's session, we will be studying some fundamentals of multi-user system, what is multiple access, and the most important and the path-breaking technology that led to huge data rates called as code division multiple access or CDMA. In today's session, two important things that we are going to note is code division multiple access and orthogonal frequency division multiple access. So let us continue. Hope you guys will enjoy this particular session. So today we will be seeing what is multiple access, and then about CDMA, code division multiple access, and OFDMA. So let us consider a system where we have two users using a common air channel. Okay, so we can imagine that there is a transmission happening from one user to the other through this common air channel. In 1G systems and in previous generation technologies, the problem what we had was that either one frequency band or one time slot has to be allocated to a user, and this particular user can access only one particular channel at one particular time. A channel is fully dedicated to one user. When it comes to multi-user systems, what we are doing is that, see, we have here one user, here there is another user, and this user wants to communicate to this one, and this particular user wants to communicate to this one. Okay, in this case, in previous systems when there was multiple access was not developed to this extent, what we had was we had an individual connection, so that this channel was not shared between different users, and each users had to use a dedicated resource. In this particular scenario, what happens is that we are wasting our resources. Am I right? So this led to the advent of multi-user systems, which gradually came to be known as multi-access systems. So in the previous two classes we have seen, suppose this one user is having one particular frequency, this user is having, or this user generates a signal to be transmitted in a different frequency so that both these people can use the same channel. This is called as frequency division multiple access. That means you have user 1 here, user 2 here, and these two users are using the same channel but with different frequencies. This is called as frequency division multiple access. In the previous session we have written some notes about FDMA. In time division multiple access, what we are doing, we are breaking this into different time slots and transmitting it. Okay. So I believe that all of you are able to understand what is FDMA and TDMA. Any doubts? The previous session we have written all the academic points that is required to answer the questions for FDMA and TDMA. In this session we will be seeing some more in detail about TDMA and CDMA. We have seen something in detail. We will be seeing more in detail about CDMA, or we are going to start studying what is code division multiple access. Okay, so CDMA has so many superior properties and is widely used. See, what happened was in the first and second generation, the communication was very limited to so many conditions. We did not have enough bandwidth, we did not have enough data rates, and so on. With the advent of this multiple access, what happens was several users were able to share a single resource. What happened is that it multiplied the facilities. It increased the facilities to a very great extent. Okay. So this is a simple diagram representing graphical representation of CDMA. You have multiple channels, channel 1, channel 2, channel 3. This goes up to channel K. Okay. Here we have time, code and frequency. So now I'm going to explain in detail how this code division multiple access is going to work. Let us imagine that we have two users. One user is called as user 0 and the other one is called as user 1. Suppose the blue signal, all throughout I'll be using blue for user 0 and red for user 1. Okay. Suppose user 0 wants to transmit a signal to this particular user and user 1 wants to transmit another one signal to the second user available here. Okay, what I'm showing it here, this one. These are two signals transmitted by two users. First user we are calling it as user 0 and the second one as user 1. Okay. Let A not be the signal that the user 0 has to transmit to this particular to his receiver. Each user has his own receiver. Let us imagine that this is the receiver for user 0 and this is the receiver for user 1. Okay. So A naught is the signal that user 0 wants to transmit to his receiver. Let us introduce a term called as C naught. C naught is a unique code. And let us give for example, I'm teaching you CDMA with example and this is the best way with which you can understand CDMA. Later on, please do not claim that I did not understand CDMA because this is the easiest way. If you have any queries in between, you can stop me and ask me. Because these concepts are basic concepts and these are the things that you need to keep in your mind throughout your life. So let us consider C naught to be a matrix, a vector of 1, 1, 1, 1, 4 ones. And we are going to generate a signal called as x0, which is A naught into C naught. You are multiplying the original signal A naught with a signal called as, with a code word called as C naught. C naught is the code and you are transmitting X naught. Similarly, for X1, the signal is A1 and you are generating another code word in which, sorry, this is plus 1, 1, minus 1, minus 1. So, sorry, there is a small mistake in this slide. When you write your notes, you can use it as 1, minus 1, minus 1 and 1. You have 2 plus 1s and 2 minus 1s. You are multiplying x1 with a1. You are generating x1, sorry. You are generating the signal x1 that is being transmitted by user 1 and the data that you want to transmit or the information bits, consider this to be A1. So A1 into C1. C1 is the code that you are transmitting and the C1 value that is given here is plus 1, minus 1, minus 1 and plus 1. Okay. I'm explaining to you how code division multiple access is working. Okay. This is going to be the basics for your coming few sessions also. So please listen carefully and try to understand. If you have any queries, you can stop me in between and ask me. Okay. So this is what we have seen so far. We have C1, I'm sorry, C1 is equal to 1 minus 1 minus 1 comma 1. Okay. Yes, it is correct in this slide. I am generating a new signal x, the value of which is x naught plus x1. What is x naught? A naught into C naught. What is x1? A1 into C1. You have generated two codes, C naught and C1. C naught is a matrix of ones. C naught has 1, minus 1, and 1. Okay. The value of x, the green signal that you are finally transmitting, is x is equal to x naught plus x1. Value of x naught is a naught into c naught. Value of x1 is a1 into c1. Is that clear? All of you? If you have any doubt so far, you can just keep asking me. So now we'll find out how we are going to extract this A0 and A1 from the received signal. You are clubbing these two signals and sending together, right? So in CDMA, what we are doing is that different users are multiplexed with different codes. Today, in this example, we have taken only two users. We can have multiple number of users. So let us consider a case with these two users. Similarly, we will be doing it for n number of users. So according to what we have done so far, x naught is equal to a naught into c naught, which is a matrix of a naughts. Similarly, x1. So I've used this convention basically simplify your understanding. I've used blue color for x naught, red for x1, and green for the combination of these signals. Okay. So x naught is equal to a matrix of a naughts. x1 will contain a1 minus a1 minus a1 and a1. And x, which is the combination of both the signals, what it will contain? It will contain a naught plus a1, a naught minus a1, a naught minus a1, and a naught plus a1. Is that clear? This x is the signal that you are multiplexed. This is the output of your multiplexer. You can get problems also based on this, so that once you understand the concept, it is quite easy for you to solve these problems. So now what we'll be seeing next is what is that we are going to do in the receiver's end. So the transmitted signal after multiplexing is x. X is known as the composite signal, and it is then transmitted on the downlink from each of the users 0 and 1 to detect their own signal. So how this detection process is going to happen is what we are going to see. At the receiver's end, what is that is going to happen? Let us take the example of the receiver of the user 0. So he'll be receiving a signal. This code is already known to the receiver, okay? This code C0 is already known to the receiver. Okay. So at the receiver, what we do? We add this with 1. Okay. That is A0 plus A1 plus this as a whole is received at the receiver's end. So when you add all these things, what you get? You get 4A naught. Am I right? Okay. A naught, these two will get cancelled. So you get 1, 2, 3 and 4. So you get 4A naught as the output of the sum of all the received signal, that is sigma I. Okay. 1 A naught, 2, 3 and 4. The others will get cancelled. So when you add up all the things, what you got was 4A naught. So next what we will see is that we will see what is happening at the the other user 1's receiver. At the receiver end of user 1, we have this value, right? 1, minus 1 and 1. We have A naught plus A1. The same signal which is received at the user 0's end is the signal that is being received at the user 1's end also. But the code here is different. Okay. Too much of red, no? I'll be using black now. The code, that is 1, minus 1, 1 is different. This is the value for C1. Now what happens when you add both these things? In the previous receivers, when A1 got cancelled and became 0, here A0 gets cancelled and becomes 0. And the value what you will be getting is for A1, right? See, A0 plus A1 minus A0 minus A1 minus A0 minus A1 plus A0 plus A1. So here you will get this as A0, this as minus A0, but this will become plus, right? You are changing the sign here. When you remove this, this will become plus, right? Yes. So here you will have minus A0, then you will have plus A1, then you will have plus A0 plus A1. So here what happens is that A0, this A0, this A0, A0 minus A0, A0 minus A0. So all these things will become cancelled. You will get A1 plus A1 plus A1 plus A1. So you will get 4A1. In the previous one, what you got? 4A0, right? So you understood how this code division multiple access works? Two signals are encoded and transmitted in such a way that they can be decoded. We have so much of algorithms with respect to CDMA, like Walsh-Hamadat algorithm, which is used to generate codes. So this is a different and a very interesting subject altogether, and there is a lot of research going on how we generate codes. So we have transmitted two signals, one for user 1 and the other one for user 0. User 0 we have multiplied with the code word C0 with the user 1, you have multiplied with the code word C1. This code word is known to the receiver also, and then this multiplied, both the signals are added and transmitted. And both the signals at both receivers end, we receive a multiple, a constant into the multiple of the transmitted signal, right? This is how code division multiple access works. Is there any queries regarding this? Any doubts or anything that you would like to ask me? And I believe that all of you have understood the concept very clearly. Is there anybody who did not understand? I'll repeat it again. So with this, I believe that all of you understood code division multiple access, right? If you have any queries, you can stop me and ask me. So this is how we got 4A1. Okay. So C0 and C1 are the codes, are generally large bandwidth signals and are known as spreading signals. For you to understand the concepts, I gave you the C0 and C1 to be very simple signals which consist of only ones and minus ones. But in reality, we can have complex algorithms. We can have so many other kinds of systems where we create codes and then we extract the transmitted signals. This way, this method of transmitting signals using codes is called as code division multiple access. Very easy and very simple for all of you to understand. Am I right? Yes or no? So this C0 and C1 is generally known as spreading signals. Some of the points we'll write and then we'll see what it is. All users in a CDMA system use the same carrier frequency and are able to transmit simultaneously. Now why is this point important? Can any one of you tell me why is this point important? Anybody? Till the development of CDMA, we were not able to use the entire carrier frequency or we were not able to use the entire time slot because we were either using FDMA or TDMA. In FDMA, what happens is that you are assigning different frequency slots. Although every user can transmit simultaneously, they cannot use the same carrier frequency, and that was one of the reasons why frequency was a major resource as such. We were all constrained with the, or we were all restricted with the frequency. In time division multiple access, what happened was users were given different time slots, so they were not able to transmit simultaneously. With the advent of CDMA, what happened was users were able to use the same carrier frequency and users were able to transmit simultaneously also. See, from this section of your syllabus, the most common question will be compare these different multiple access systems. That is why I am giving you points, and towards the end of this class, we will be seeing all the major differences between TDMA, FDMA and CDMA. Okay, I will be giving you the skeleton, the rest of the things you have to make it up. Is that okay? For the detection of the message signal, the receiver needs to know the code word C0 and C1 used by the transmitter. This is one of the important limitations or one of the difficulties that we face with code division multiple access. So we have infinite number of algorithms and there is a lot of research going on for development of this kind of codes. So many codes are there. Say for example, so many error codes are also there. How so that we can develop a system. The resources were open to many. We didn't have frequency limitation or band limiters. We had the increased data rates. We had multiple users using code division multiple access. So, unlike TDMA or FDMA, CDMA has a soft capacity limit. That means that there is no absolute limit for the number of users in a CDMA system. Multipath fading may be substantially reduced as the signal is spread over a large time gap. So there is no delay spread, right? So what happens is that the multipath, all the problems that is caused due to the multipath fading is highly reduced. The next point is that the channel data rates are very high in CDMA systems. Okay. You know why the data rates are high? Signals are transmitted over the same carrier frequency and simultaneously. I've been repeating this now. Are you able to understand? So that we got high data rates. Another one problem is that self-jamming. What is self-jamming? Spreading sequences of different users are not exactly orthogonal. Okay. As it is already mentioned that we have a large spread and so it is not uniform. This will cause what is known as self-jamming. Next important point is what is orthogonal frequency division multiple access or OFDMA. The principle of OFDMA and how OFDMA works is all based upon OFDM, and the details of OFDM is something which we have seen in the third module, orthogonal frequency division multiple access. OFDMA achieves multiple access by assigning users disjoint sets of subcarriers. We have seen this in detail in the previous modules, especially in the module 3 where we have seen multi-carrier modulation systems, MCMs. The basic principle of FDMA depends upon what OFDM is. Okay. So multiple access technology based on OFDM is termed as orthogonal frequency division multiple access. So instead of looking in detail about the technology, which we have already seen, we'll see a few points related to advantages and disadvantages of OFDM, which you may need to write in your exams, which can be asked in this module also. In OFDMA, multiple symbols can be transmitted in parallel while maintaining a high spectral efficiency. Advantage: high spectral efficiency. Because the radio channel is divided into many narrow band, low rate, frequency, non-selective subchannels or subcarriers. OFDMA enables different media such as video, graphics, speech, text or other data to be transmitted within the same radio link. This is one of the major requirements of this generation. As we go on, we need to transmit more amount of data with the same radio link. Okay. So this is one of the ways OFDMA, this is one of the major advantages of OFDMA. We are not seeing OFDMA in detail now here because OFDMA is nothing but OFDM. You know OFDM what you are doing? How many of you remember OFDM? In OFDM, what we are doing is that in multi-carrier system, what we are doing is that we have what is called as IFFT, right? We are taking the Fourier transform of the signal that has to be transmitted, and we are generating multiple orthogonal signals to be transmitted over the same channel bandwidth. Am I right? Yes or no? What happens is that when you do like that, you have so many advantages. I told you why we are doing all these things. First thing is that we have a huge amount of data rate. I mean, the fast data is being transmitted very fast, more effective multiple access and so on. But we have a limitation also. You know, remember with the cyclic prefix. Cyclic prefix is an important topic in your OFDMA. Another one disadvantage, peak to average power ratio. We need to add a cyclic prefix in order to reduce the intersymbol interference that is being caused between adjacent signals or caused between the signals in the multi-carrier modulation technique. Right? In order to overcome this intersymbol interference, what we do? We add cyclic prefix, and indirectly what happens? You are increasing the space, right? You are adding something more to the data which is not, which may occupy some more bandwidth. So cyclic prefix is another disadvantage. The need to add cyclic prefix. Another point is that peak to average power ratio increases n times. We have derived the equation for TAPR in the third module. So we have specific types of services and their quality requirements. So let us see some disadvantages of OFDMA. Increased PAPR, peak to average power ratio, in comparison with single carrier systems, and requires a large linear range for the OFDM transmitter output. In single carrier output, PAPR is equal to 0 dB, while in OFDMA it is equal to N, right? Where N is the number of subcarriers. So it is increasing N folds. Or if you take it in the normal words without dB, it is 1 and N. Let's look into the next disadvantage. OFDM is highly sensitive to carrier frequency off shift. Comparison between TDMA, FDMA and CDMA. In some of these points I will be using only TDMA and CDMA, or TDMA and FDMA, depends upon this. First thing is that already discussed, TDMA is a time division multiple access, frequency is FDMA, and in code division what we are doing is that we are creating codes, and then we are dividing this full radio channel into different codes. So all the channels are active for a short period of time on the same frequency. So all the channels are active for a short period of time. See, the basic difference between all these things, what is this difference? You cannot transmit using either same carrier frequency or continuously, simultaneously. In TDMA you cannot transmit simultaneously. In FDMA you have to use multiple carrier frequencies. In CDMA you can do both these things. In TDMA signals are separated in time domain, signals are separated in frequency domain, signals are separated using different codes. The next difference is about the guard time. Guard time is between different time slots. Here we need guard bands between different frequency bands, right? In CDMA we need both. The next point of difference, so this is the same point. In TDMA or FDMA, the cell design requires more frequency planning, which is a tough job. In CDMA, it is quite minimal because we have built-in algorithms and we don't need to have much frequency planning. There is no need for code words in TDMA or FDMA. In CDMA, we are using a code word. The code word is known both to the transmitter and the receiver. In TDMA, bandwidth available for transmission is small, which leads to quality, which leads to compromise in transmission quality. We have a smaller, see for all these things, both TDMA and FDMA, we have a limitation with respect to bandwidth. In CDMA, we are using the entire frequency spectrum. So whenever you use the entire frequency spectrum, what happens? The quality naturally increases, right? I believe that these points are obvious and you can understand by simply reading it. You don't need much explanation. Just making you understand this topic is very easy. TDMA is a band limited system, whereas CDMA is a power limited system. When it comes to TDMA and FDMA, we concentrate on we concentrate on exploiting the entire frequency band that is available. But for CDMA, we are more worried about the power constraints. With the advent of DSP techniques, now we have multiple digital processing techniques so that we reduce the head time. See, the main disadvantage of TDMA is that you have an overhead time. We have so much other information that has to be transmitted. The guard time. Okay. So with the advent of DSP techniques, we are going to reduce all these complexities there. Whereas in FDMA is much more simpler. CDMA is also simpler when compared to time division multiple axis. So here we have the main disadvantage of TDMA is that we don't have any continuous means of transmission and it's all based upon the time. But FDMA you have continuous. In CDMA you have both. In code division you can add that point also. CDMA, you have written CDMA, you have simultaneous and you have the ability to use the carrier frequency also. Have you all written down? TDMA is less expensive, FDMA is more expensive, CDMA is also not that expensive. We don't have much. So with this we are coming into the conclusion of the fourth module, and in this particular part, that is 4.3, one of the major questions, any question that comes in your exams will be related to comparison of different multiple access schemes. Okay. So do you have any queries to ask? These points are some things that I want you to reproduce in your exams. So thank you all. Thank you for listening to me. In the next class we'll be starting fifth module, and we have completed successfully the fourth module.